Hello and welcome to the sixth video of this series on how to use the TI Inspire. In this video, we'll learn how to use more of the functions in the Algebra menu, things like how to factor, expand, complete the square, solve systems of equations, all that good stuff. So I'm just going to start going in order. By the way, if you do not have a CX CAS, I know this is something that just the regular CX is not able to do. A lot of these things in the algebra menu. So if you have one of those, just follow along. You can use the stuff that I talk about. I guess if you can't use it, then I guess I don't really know. So I'll go to menu, and then number 3 is for algebra. And we already went over how to use the solver in a previous video, so I'm just going to go straight to factor. So this factor is pretty much just like it sounds. It'll help you factor a polynomial. So let's say I have x squared plus 3x plus 2. You give me x plus 1 times x plus 2, right? This can be really helpful if you're trying to factor the denominator of a function to see where it's equal to 0. That's a pretty common time that I would use factor. Another thing that you might not expect is that you can actually use this to just factor like regular numbers. So if I type in like 98, it'll actually tell me the prime factorization that way. All right, going the other way, you also have expand. So algebra and then expand. And I'm actually just going to copy this down here to show that it does it correctly. So if I expand it, it gives me exactly what I started with. It gives me that x squared plus 3x plus 2. All right, so that's expand. The other thing that expand does that is pretty useful is it will do partial fraction decomposition. And a lot of you have probably seen this, and maybe you just don't know what it's called, but I'll show it anyway. Let's say I'm dividing x squared plus 5x plus 6 by x minus 2. So when I divide this, you see it'll give me, x plus 7, right? That's like my linear part. And then it'll also give me this 20 over x minus 2. So it'll do like the long division. This technically isn't partial fraction decomposition. I got a little bit unlucky. Let me do a better example. This is an example of it doing long division. This one right here. This is a better example of partial fraction. If I go like this. Yes, okay. So it factors this denominator, right? X squared plus 5x plus 6 will factor to x plus 2 and x plus 3. And it'll express it as the sum, or in this case, the difference, or the combination of two fractions with these as their denominators. And this can come in really handy whenever you're trying to whenever you're trying to integrate stuff, whenever you're trying to integrate things like this. The other use it has is sometimes he'll simply just ask, what is the partial fraction decomposition of something like 2 over x squared plus 5x plus 6? And this will be the whole thing, right? Sometimes the questions will really just be that simple. Okay, the next thing is, well, I'm gonna clear this first. Let's go to algebra and then complete the square is the next thing. This one's pretty useful for things like conic sections whenever you're going to have to be completing the square to get it into like a standard form. But here's how you type it in. So let's say I'm trying to complete x squared plus 6x equals 0, comma x. And I do comma x to tell it that I want to complete the square on the x. So when I do that, you see it gives me x plus 3 squared equals 9. There's a few different variations of this. If I take away the equals 0, you see it will just assume that it's equal to 0 and then leave that 0 on the right-hand side. It can also complete the square for multiple variables. So let's say I had x squared plus 6x plus y squared minus 4y. And let's not set it equal to 0. And let's say I do comma x, comma y. Okay, the comma x, comma y tells it that I want to complete the square for the x and the y. Notice if I just leave it as comma x, right, it'll complete the square for the x, but not for the y. So like this. If I wanted it to create it in terms of an equation, I would just, in here, I would set this equation equal to 0. And you see now I get this in full, this will be the equation of a circle, but I would get this in the full completed form. Okay, this next one is something you're going to be using quite a lot, and I think this saves a lot of time compared to doing it with the graph, doing intersection on the graph. But if you go to algebra once again, number 7 for systems of equations, and number 1 for systems of equations. The solve system of linear equations you won't really ever use because you can solve linear equations in number 1. Like you can do everything you can do in the number 2, you can do in number 1. So it'll pull up this menu, it'll ask you how many equations you want and the variables you want to use. So I'm just going to stick with 2 equations and then these variables. You can change how many equations you want if you just type in a different number, and of course you could delete, type in a different one. And then to get to the next menu, right, to get to like the variables, you just click tab. In general, if you click tab, you'll get to like the next thing in the item box, in the menu box. So I'm gonna stick with 2 equations, x and y, and I'll click OK. And let's say I want to solve these equations, y equals x squared, and then y equals, I'll also do like y equals x. Okay, so it gives me these 2 solutions, x equals 0 and y equals 0, or x equals 1 and y equals 1. That's pretty much what we would expect. For those of you that watched the solver video, you can also put these while statements out in the back. So maybe I only want the solutions where x is greater than 0. So I type this out back, and you see it omits this one. It doesn't include this x equals 0 because 0 is not greater than 0. So it'll only give me this one value. This can be useful sometimes, like if you're trying to solve a system of equations where maybe x represents distance, right? Maybe x represents distance or time, and you only want positive values because that's the only case where it makes sense. So that's an example of where you would want that. You can also do it for y, right? In this case, it gives you the same answer. And I believe, I may be wrong about this, but I believe you can actually put 2 stipulations out front. If I just type and, like that. Yeah, so in this case, it didn't change the answer. But you can put these 2 out front if you have like a bunch of solutions. Maybe you're doing a system of equations with trig functions. That's a pretty common one where you get a bunch of solutions. Okay, the next thing is the trigonometry like simplifier. This will help you simplify a lot of your trig expressions. So go to 3, and then trigonometry, and then you have 2 options. You have expand and you have collect. So in general, the expand is going to take your equation and make it longer, and your collect is going to take your equation and make it shorter. But sometimes they don't do the best job. Sometimes they just sometimes they don't really do what you expect them to do. But if that's the case, you just go back and use the other one. So let's say I want to expand the sine of 5x. If I click enter, it gives me this full expansion. It's actually pretty long. It gives me that full expansion. Well, if I wanted to have, let's say I had this, and I wanted to collect it back down, I wanted to simplify it back down, I would go back to my trig and I would click collect. Or wait, I didn't put it in the right thing. I click collect, and then this, and you see it simplifies it all the way back down to 5x. Something that the calculator will sometimes do, and I'm not 100% sure that it'll work for this case, but sometimes if you just type this in without any like extra things and click enter, okay, it didn't do it in this case. But for example, like for some of your more basic trig properties, let's say I did 1 minus the sine of x squared, right? If I click enter, it will actually just simplify it for me right there. It doesn't require any of the trig expand or trig collect. There's some that are just basic enough that it will simplify it for you, right? Of course, you may recognize this as the Pythagorean identity, right? Sine squared x plus cosine squared x gives you 1. So for some of these more basic things, it will just simplify it for you. And then for the last thing, the very, very last thing, the next one that's actually pretty useful is this complex solver. I know I'm skipping a lot of stuff, and that's pretty much to make sure this video isn't 30 minutes long. I'm skipping this stuff because I feel that certain things are more useful for the math test than others. And once you get a feel for the things that you would use on the math test, once you're comfortable enough with those that you would recognize, oh, I want to use this part of the calculator for this part of the test, you'll be comfortable enough with it that you can kind of figure out how they work on your own. So, if there's something that I skipped that you think that you've like heard from a friend, it's like, oh, this is super, super useful. Please like make a video about this. Then, feel free to leave a comment. But the last one we're going to do is this complex, and I really only use this complex solver. So what this will do is it's the same as your regular solver, except now it will give you complex solutions. So let's do a very basic one. We'll do x squared equals -1, comma x. So of course, any real number squared would give you a positive number, but if we allow ourselves to venture into the imaginary domain, then if I click enter, you see it gives me these two solutions of I and -I. A pretty common use for this is he'll ask things like, which one of these is a third root of like 1 plus I? That's a common example. So if I wanted to know the third roots of 1 plus I, and remember, you have to actually go to I, you can't just type the letter I. Yeah, which of these are like one of the third roots of 1 plus I? I type it in here, and when it solves for x, it would take the cube root of 1 plus I. And so these are a bit complicated in terms of what the numbers look like. I probably could have picked better numbers. But you see, this will give me all of my cube roots. I don't believe so. Since this is divided up into like a real number and an imaginary part, you can't do the things in the such that where it's like such that x is greater than 2 because it doesn't make any sense in this context, right? Imaginary numbers are like two-dimensional, and so it doesn't really make any sense to limit it to just the one dimension because it. Anyway, sorry. Long story short, you can't use the such that in this case. So that's about it for the algebra section. I will add in just a little bit of an extra teaser for those of you that stayed around this long. This kind of fits under the algebra, but it's not under this menu. I'll fit in this little sneak peek. Let's say you're trying to find the domain of a function. And sometimes they'll ask like some pretty complex ones, and maybe you're not too sure whether or not you're doing it correctly. If you just type the word domain like this, you see how it goes straight up and down like that. It's no longer italicized. That means we've turned it into a function. So let's say that we're trying to find the domain of like square root of x, right? This one's not too hard. We know that x has to be either 0 or positive. It can't be a negative number because then you would get into the imaginary stuff. But if I just type my equation and comma x, it will tell me the domain of this equation. So in some more complicated situations, say you had something like square root of x minus 3 over x squared plus 5x plus 6, and let's say we're taking like the logarithm of this. Okay, that didn't work. Okay. Yeah, so this is a pretty complex problem. And I do comma x, and it just gives me the domain just like that. So, that's a little bit of a sneak peek. Not a sneak peek, just a little bit of an Easter egg for those of you that stuck around for the whole video. So, if you learned something, make sure to leave a like and subscribe. If there's something you want me to go in more depth, or if you just have any questions about this general thing about our algebra menus, then feel free to leave a comment, and I will see you in the next video. I'll see you next time.